Hello, so here's a couple slides on make them balance, which I know some people had a little trouble with. And so I encourage you, whenever you have a Desmos activity, to just try a few things out and adjust your answer if it doesn't work. So without really knowing what's going on, it just says find values for X and Y so that the hanger balances. Let's just try 2 and 1. I don't know. I click on that, then the little graphic shows me, okay, the left side was too heavy, the right side was not light enough, it got pulled down. So let's just, I don't know, try to make this 10, see if that's better. Okay. No, that was the right side was too heavy. So we can just keep trying to mess around. Maybe, I don't know, maybe 8 works. Okay, not as bad, but a little better. And we try 7. Just by guessing and checking, you can kind of get a feel for how it works. You're trying to make the two sides the same weight. Now, if you look down here, we have an equation, y equals 2x plus 3. So if I want to try another here, let's try, we know that 2 and 7 works. Let's do 1. If I do 2 times 1 plus 3, 2 times 1 plus 3 would give me 5. Let's try 5. That looks good. Let's try just one more here. Let's say x was 0. 2 times 0 plus 3 would be 3. And why does it not let me do that here? Ah, okay, it's not letting me use 0. Okay, that's fine. Let's try 0.5. If x is 0.5, 2 times 0.5 is 1, plus 3 more is 4. So what I can see here is that whatever number I want to try for x, if I go 2x plus 3, I get this combination for y. I could even start with a y value, minus 3, and then divide by 2, and I'd get an x value. So let's keep rolling. Okay, now notice and wonder here. There's a lot of different x and y points that balance, and what do I notice? It looks like they all line up. And that's exactly right. We've been studying this sort of an equation here. 2x plus 3. It's going to have a y-intercept of 3. It didn't let me get all the way to the y-intercept, but I got close. It's going to have a slope of 2. So I got 2 points that are right next to each other. They go 2 steps up. The rise is twice as tall as the run. Now if I look here, we have a different equation. Same sort of idea, but instead of typing the numbers in, I got to move the point. Now it's 2x plus y equals 15. Let's put it at a random spot here. 2x plus y equals 15. Might have got lucky. 2 times 5 is 10, plus 5 more is 15. Let's try it out. I think that's going to be okay. Let's try another one. Let's try this. I don't know if this will work. Okay, that's not heavy enough. I'm going to try to move it up a little bit. Let's try to move it up here. Will that work? Not quite heavy enough. So how can I be sure, rather than just doing guess and check? Can use my equation. 2x plus y equals 15. So let's say I had x is equal to 2. If x is equal to 2, I've got to go 2 times 2. That makes 4. 4 plus 11. I got to go all the way up here to 11. That's great. Let's try another one. Let's say that x was nothing. If x was nothing, I'd have to add 15. Let's try even one more. Let's say that y was nothing. Well, then I would need to have x be 7.5, because 2 times 7.5 makes 15. So that's your idea here. We'll do just one more slide here, and we'll call it good for this video. Now this is starting to look like our new stuff with systems of equations. We got 2 different hangers. These are the 2 ones we were just working on. And it's asking, is it possible to balance just hanger A? Well, any point on the line, any point on the red line will balance hanger A. Similarly, any point on the blue line, or is it a purple line? Any point on the other line will balance hanger B. But there's only one point where you can balance both of them right there. And why does that point work? Because 2 times the x plus 3 is the y. 2 times 3 plus 3 is 9. Why does it work for hanger B? Because 2 times x plus y is 15. 2 times 3 plus 9 is 15. Now, is it possible to balance neither? Sure. Put the dot somewhere else off the lines. Okay, so that's the idea here, is that when you're looking at a solution to a system, you're looking for the point that balances both hangers, the point that makes both sides of both equations true, the point that is on the intersection of the two graphs. Please make sure you go back and finish up this activity.